Hi, today we're going to go over how to use adding and subtracting radical expressions. Before we go into the intense stuff, here are some terms you should familiarize yourself with. Rationalizing the denominator is when you eliminate radicals if the denominators or fractions are involved in the radicand. That's the number inside the square root box. Like radical expressions are just when the radicand and the indice are all like. And with conjugates, that's when the numbers involved are all rational. And in case you're wondering if you can use any of this in the real world, you can use it in trigonometry or geometry with carpentry or masonry, or in electrical engineering. So the first example we have is the square root of 12 plus the square root of 48 minus the square root of 27. 12 factors down into 3 and 4. 4 is a perfect square, so it factors down to 2. 3 isn't a perfect square, so it's left inside the radicand. 48 factors down into 12 and 4. 12 is factored into 4 and 3. 4 is perfect, so it becomes 2 and left outside the radicand. Once again, 4 is factored down into 2, and you multiply those two 2's together and you get 4. The radicand still being 3. Lastly, you have 27, which can be factored down into 9 and 3. 9 is a perfect square, so it becomes 3. And then 3, and then you're left with another 3 that isn't perfect, so it's the radicand. The last bit is the easiest, where you just add and subtract as you usually would. So you're left with 3 to the square root of 3 as your answer. The example for today is the square root of 98 minus the square root of 72 plus the square root of 32. 49 and 2 are what 98 is factored down to, and 49 is a perfect square, leaving you with 7 with a radicand of 2. 72 is broken down into 8 and 9. 9 is a perfect square, so immediately goes to 3. 8 is factored down into 4 and 2. 4 is broken down even further into 2. Because you have two perfect squares, you multiply them together outside of the radicand, so you get 6 to the square root of 2. Lastly, the square root of 32 is factored out into 16 and 2. 16 is a perfect square and becomes 4, leaving 2 as the radicand. So your final equation is 7 to the square root of 2 minus 6 to the square root of 2 plus 4 to the square root of 2. You add and subtract, and you get 5 to the square root of 2. And that's it. Hope this was useful.